Hello, my name is Neela Krishna. I am here to present the task 2 given by the Sparks Foundation internship program. The task belongs to Data Science and Business Analytics and internship. I am from April 2024 batch. So the objective of the task is to find the optimum number of clusters using unsupervised learning algorithm K-means clustering of a given iris data set. So for that, I have imported some Python libraries here, as can be seen in the Jupyter notebook. NumPy, Pandas, Matplotlib, and Seaborn. So the NumPy library basically used to perform numerical computation of the arrays, and Pandas library used to read the CSV and Excel and other kind of files, and other some and to represent the data set on a data frame. I imported Matplotlib and Seaborn libraries here. So both are used for Python data visualization here. Seaborn is rather more efficient than Matplotlib because it requires less lines of code as compared to Matplotlib, and Seaborn is built on top of Matplotlib. So I have read the given CSV file in the task. So I have imported in pandas as PD. So PD dot read under CSV iris.csv, and data has been saved into the df data frame. For reading the first 5 rows, I have written df.head. So here is the sepal length, sepal width, petal length, and petal width are the size, and we can say it's the properties of the species of the iris flower. As can be seen that the ID column is not required here. So I have dropped the ID column and I put in place equals to true to make the changes in the data frame itself. And after that, I have again read unit df.head. As can be seen that ID column has been removed. And after that, I try to find the number of samples in each category. So for that, I have written df species dot value underscore counts method. So it gives the number of samples of each species of the iris flavor, iris setosa, iris versicolor, iris virginica, each having 50 samples. So the data set is fully balanced here. This is just to represent it in the list here. Df species dot unique dot to list. So after that, I have separated. Uh, uh, I have written the uh, df.ilog comma 0, 1, 2, 3 dot values. So basically, I tried to uh, represent the data frame into a array of array of values here. So for that, I have taken label position based indexing here ilog, and this represents the from zeroth row to last row of entire data frame, and the columns I have chosen first, second, third, and fourth. As the indexing starts from zero, so zero represents the first column here, sepal length. Species I have not taken here because it is basically used further to plot in the uh, uh, to represent the plot afterwards. So the objective is to find the optimum number of clusters. So for that, I have used elbow method. So first I imported K-means algorithm using sklearn.clusters, scikit-learn cluster library, and I have initialized a list here, wcss underscore list here. So after that, using a loop, using for loop, I have taken from 1 to 10 range for I in range 1 is to 11. I have written. I try to find the optimum number of clusters. So for that, I have started a for loop here. So k means n cluster equals to I. So for every value of every value of I, the model k means algorithm got trained on the data set here. Initializer I have taken k means plus first random state equals to 42 to give the same result on every loop of the run. So k-means dot fit to fit the model with the training data set, and after that count k-means dot inertia underscore. This term represents the within cluster sum of squares value, and basically it was appended into the empty list here that we initialized here. So for every value of I, we got a different value of within cluster sum of squares, and got appended into the empty list here. After that, I have written plt.plot. So I used plot method from range 1 to 11, and this is the WCSS underscore list that got populated from the KMeans.inertia underscore value. So here is the x value range 1 to 11. This can be seen here, and is the y value is the WCSS underscore within cluster sum of squares value for every value of I. The title of the property elbow method, and x level has taken number of clusters, and y level is within cluster sum of square underscore list. So the graph here shows the elbow method here. So as can be seen from here that at, k equals to 3 value, as can be seen here that at number 3 can be taken as the optimum number of clusters, because as can be seen from the WSS list that we have populated in the for loop, the there is a significant drop from uh, first to second and after third. But after that, there is a drop in the within cluster sum of square value, but there is not a significant drop here. So this value can be taken as the optimum number of clusters. So for the sake of simplicity, I have taken k equals to 3 as the optimum number of clusters here, because as can be seen from here, that the within cluster sum of square value does not get reduced significantly beyond this. So k equals to 3 is taken as the optimum number of clusters here. Now after that, training the K-means model on the data set. So we have taken n equals to equal to 3, initializer K-means plus and random state are taken an arbitrary numerical value. After that, I have taken fit underscore predict x. X is taken as the data set here. This one, it basically dot values convert the data frame into a numpy array here. And fit and under after fitting, it means after training the model, got predict to have to predict also. So I've directly written fit underscore predict here to get the predicted value, y predicted value. And after to find out the y predict value, you can see here the 0, 1 and 2. Here are the predicted values. Now for each iteration of the cluster here, the centroid gets updated every time. Basically, it's how the algorithm works. So k-means dot cluster underscore centers I have taken as the centroids value. Now for the sake of simplicity, I have to uh, plot the all the three species of the iris flower on the 2D plane. I have taken a dimensionality reduction step, principal component analysis here. So I have imported from the scikit-learn's decomposition library, import PCA. So I have taken number of components equals to 2. X underscore PCA dot fit underscore transform X value. And after that, PCA transform centroids also. Because it's quite difficult to plot all the 4 columns into a 2D plane, it becomes difficult to visualize. So I've taken a dimensional reduction step here. After that, after creating a data frame for easy plotting, so PD data frame X underscore PCA value that we got here in the previous cell here, and columns have taken PC1 and PC2, just named at the column. And iris cluster, I have created a new column in this iris data frame, and that y underscore predict that we predicted previously here. And iris species, another column I have created, same as DF species here. So again, the new data frame becomes PC1, PC2, cluster and species are the 4 columns here. Now the final step is to visualize the clusters. So I have taken plt.figure method. I have taken figure size 10, 6, and using C1 library, I have plotted a scatter plot here. Now data set is taken as a iris data frame here, as we have created previously here. On the x-axis, I have taken principal component 1. So in short, I have written PC1, and y is taken as principal component 2. So this one. Hue is taken as a cluster. So actually, there are 3 clusters here. So hue will represent the 3 different data points here, 3 different categories of data frames. Palette is viridis, style of species. Style I have taken the species, 3 different species. So 3 different styles here. And size of each data point is 100. After that, again, I am using PLT dot scatter using PLT method. We have to plot the centroids also. So centroid is underscore PCA that we have calculated previously. this one. So first centroid and the second centroid. Each size of the centroid is 300, uh, quite larger than the other data points. And the color of the centroids is red. Label centroids and marker is X. So as can be seen that there are three different species here. X is the red X color is taken as the centroid here, and then PLT dot scatter. K means clustering of various data set to this here. Basically, the title here. X label is principal component one, Y label is principal component two, and to represent the legends here, this one is the legends here. So the basically represents the different clusters, 0, 1, and 2, and the PLT dot show method. So I got this one. So